Hello, in this video I'm going to continue working with negations and indirect derivation, but with some slightly more complicated examples. Okay, so let's show our conclusion. Negation of if p then q. Let's make an assumption. We can't do conditional assumption because we're not trying to show a conditional. We're actually trying to show that the conditional is false. So the last thing we want to do is argue from the antecedent to the consequent. We want to say you can't do that, so we'll make an indirect assumption. And here are our two premises. Now, can we do anything? Well, we have two conditionals on line 2 and 4. 3 is not a conditional. 3 is the negation of a conditional. But we have conditionals on lines 2 and 4. So we think, well, can I apply some inference rules? Well, it'd be modus ponens or modus tollens. We don't have what we need for those. So this derivation is stuck. What do we do when it's stuck derivation? We do a subderivation. Okay, well, what subderivation should we do? We should do a subderivation that will help us hopefully to box and cancel, that will let us box and cancel. If we can't do a subderivation like that, then we do a subderivation that lets us apply inference rules. Okay, well, so we want to get, how are we going to box and cancel? Well, it's not going to be with CD because we're not trying to show a conditional. It's probably not going to be with DD, and we did start with an indirect assumption. It's probably going to be with ID. So that means we want the negation of, or unnegation. We want the contradiction of 2, 3, or 4. So we want not if P then Q, we want not if Q then R, or we want if P then R, right? 6 contradicts 2, 7 contradicts 3, 8 contradicts 4. So we want to get one of these. So the question is, which one should we try to show? Well, what if we tried 6? What should we do here? Well, we want to show the negation of if P then Q. The only assumption we can make is if P then Q. This is not going to get us anywhere. We are trying to show something new at 6. Negation of if P then Q doesn't show up anywhere earlier in the derivation. But the problem is when we make, the only assumption we can make is if P then Q, and that's not going to help us complete that subderivation. There's nothing new there. And also, we know how to use line 2, MP or MT. So there are two reasons why 6 is not great. We know we have some sense of what we could do with 2 if we got P or not Q. And the assumption we can make looks like it's not going to help us complete that subderivation. So doesn't look like a great idea. Okay, how about 5? Well, this seems like a better idea. On the one hand, we have no idea what we can do with 3. The only way we really know how to use 3 is because it's a negation of a conditional. We can't use our MP or MT with that. We can use ID with 3 if we get 5. So 5 is really the only way to use 3 that we know of right now. If we can get it, right, we can say, 3, 5 ID. That's a way to use 3 because we're citing it there. We don't know what else to do with 3. So it looks like this is really the only way to use 3, and we do want to use everything. And we can get a good, helpful assumption with it, because we can use P with other stuff. So 5 looks like it would be useful, and it looks like it's a subderivation we can complete because we get a helpful assumption. So let's see what we can do with P. Let's see. Well, we can use P with line 2. We can say 2, 6, MP. We use Q, we can use it with 4. We can say 7, 4 MP, and we get to R. Can we use R? We can. R is the consequent of line 5, so we can say 8 CD. And look, now we have a contradiction. So, when the derivation is stuck, and you are going to do a subderivation, you want to do a derivation that will hopefully let you that will allow you to box and cancel. That's the kind of subderivation you would like to do. And if there's a negation of a sentence, if you have a negation of a complex sentence, then the best thing to do, or one of the best things to do, is to show the unnegation of that complex sentence. So we have 3, we have the negation of a conditional. So 5, we say, okay, I'm going to show the unnegation. I'm going to show the conditional, and that's going to let me do an indirect derivation when I'm done. Okay, let's look at some more. Let's get rid of this. Good, okay. So let's show the conclusion. Conclusion is R. Let's make an assumption. Let's make an indirect assumption because that's the only kind we can make. Let's put in our premises. Okay, can we do anything? Well, with 3, we would need P or not Q for MP or MT, neither of which we have. For 4, for MP, we need if not Q, then not P, which we don't have. For MT, we need not R, and that's what we have on line 4. So let's do 2 for MT. Good. Okay. Well, let's see. So now we've used 2 and we've used 4, so 3 and 5 are the things we haven't used. We still can't use 3 because we still don't have P or not Q for MP or MT. Line 5 is the negation of a conditional. So we can't do MP or MT with it because it's not a conditional. So we're kind of stuck. The derivation is kind of stuck. So we should do a subderivation. What subderivation should we do? Well, continuing with this theme, if we have the negation of something complex, one good thing to do is to show the complex sentence itself. So we could say show, and then we can come up here, and we can copy this in. So we want to show if not Q, then not P, because once we're done with this, we can say 5, 6 ID, and that will be nice. And because we're trying to show a conditional, we can make an assumption. We can say, well, a conditional assumption, we can assume not Q. Remember, when you're trying to show a conditional, make the conditional assumption. Don't make the indirect assumption. It doesn't help you. You don't know how you can't do anything with it. Okay, so we have not Q. Can we use not Q? Yeah, with 3, we can do MT. 3, 7, MT. Hey, that's not P. That's the consequent of line 6, which is what we need for CD. There we go. Let's try that again. And hey, so that's 5, 6 ID, and we are done. Good. Let's look at another one. One more. Yes, we want 5. Okay, so let's show the conclusion. Conclusion is Z. Okay, let's make an indirect assumption. Good. Premise 1, premise 2. Okay, so can we do any useful rule applications? Well, 3 is the negation of a conditional, so not much rule-wise we can do with 3. 4 is a conditional. Its antecedent is P, so if we have P, we can do MP, but we don't have P. Its consequent is if not Q, then Z. So for MT with line 4, we want the negation of that conditional. We don't have that either. So the derivation is stuck. When the derivation is stuck, we do a subderivation. So what should we do a subderivation of? Well, we have that negated conditional on line 3, so it would make sense to do to derive the conditional, because then once we get it, if we can complete this subderivation, we'll have a contradiction for ID. So let's make an assumption for CD. So P. Can we use P? Yes, we can for 6 modus ponens. If not Q, then Z. Can we use if not Q, then Z? Well, is not Q anywhere? No, so we can't do MP. What do we need for MT, not Z? Do we have negation Z anywhere? We do. We have negation Z on line 2, so we can say 2, 7, MT, and we get not Q. What should we do with not Q? Well, we're trying to show a conditional. Consequent is Q. So if we can get Q, we can do CD. We can get Q because we can get rid of the 2 negations on 8, and so we can do CD. And now we're done because 3 and 5 contradict one another, which is what we need for an indirect derivation. So I hope this is making sense. When there's a negated blah, 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 show blah, blah, blah if the derivation gets stuck, because if you complete that subderivation, you can do an indirect derivation. So there you go. If you have questions, please post online.